Hello everyone. So today we are going to talk about the association mining. So it's a narration of the frequent pattern growth algorithm. So from the last session, we looked at a prior algorithm for association uh, analysis, but it was not efficient due to its main drawbacks. At each iterations, there is a candidate set which is expensive. Furthermore, it requires us to repeatedly scan the database. Therefore, the process will take much longer time. To solve these drawbacks, we have the introduction of the FP algorithm. So, for the before how it works, so we need to at first step we construct an FP tree whereby the node of the tree contains item set with their support count. Then we draw association from the nodes to the branches, which also contains items set together with a support count. The next step is to mine the frequent pattern from the FP tree, which is by dividing the database into the projection. For each projection we have to mine the association. So let's build up the as you can see over here. So I'm drawing this. T100, 200. We can put like anything, any name, right? Like any word. Let's put cookie on it. I. So monkey can be a set of items purchased. This algorithm is based on probability. For example, from the item set of T100, if a buyer purchases an item M, then what is the probability of purchasing an item O? So the next step, enlist the item without repeating. So let's make the other one. So it's like same thing. So it's with the item sets. So there is no difference at all. Monkey. So DONKEY donkey. Make MUCQ monkey and cookie. So now we're gonna separate the enlisted items and supported counts. So for enlisted items, and here we're gonna put the support count. So let's go with the M first, so we can count how many M we have. So it's gonna be 1, 2, and 3. So it's 3 and KEY. I think we already have that thing. Yes. Okay. So O. So how many O we have? 1, 2, 3, 4. But when the word have like two same things, so it's gonna count as 1. So we're gonna still write 3. So and there is 2. There is 2 and K. For K, I think we have it's 5. And for the E, it's 4. For the Y, it's 3. And let's go with now we're missing D. So D is 1. There isn't the A. A is also 1. So mu. So u, it's gonna be 1, it's gonna be c is 2, 1 is 1. So we're gonna cut this up. This 4 is gonna go cutting this, and also 2. So let's say suppose we are given a minimum support of 3. It means items under minimum support are discarded from the list. We cancel the items before minimum support as shown above over here. So the remaining list forms of a new set known as a frequent pattern listed in decreasing order. So let's make that thing. Let's give this name set L. So TID and item sets. So it's gonna be so we had K, we had 5, this 4, this 1. So we're just gonna KE, M is also 3, O and Y. It's gonna go from like a decreasing order. So the table set L can be extracted by counting the number of each instances. For example, counting K, you will get 5E, 4M. There is like O is equals to 3 and Y there is like 3Y. As on below, you will see the instances of Y highlighted in the blue are in 5 in total. So let's do that. TID and item sets. So T100, T200, T300, T400 and T500. So M, O, N. So K. Let's make K as in dark, because this is what we're talking about right now. And K. So 2 M A K E M U C K E Y. The last one is C O O K I E, cookie. So now let's do again. So it's the same thing, but I'm only repeating this thing. M O Y. So that's the 5 we took out from here. So E is 4. So with the set L and item set, we come up with an ordered set that contains set L in each transaction as shown here. So now we're gonna make a table for the ordered set. So how it's gonna work. So it was, so it's like this: K O Y, K E O Y. It's gonna be K, have M here, K M Y, K E O. So this order set over here is extracted as shown below. Let me make this thing. TID item sets that T200, T400 and T500. So MONKEY DONKEY. The other one is MAKE MUCKY. COOKI. Yes, it's cookie. So from here, so this is our set L. This is same like this here. So now we're gonna construct something like this. So item sets. So this is the same thing like this over here. Y. And from here, so this is the ordered set. Y K E O Y K E M K M Y K E O. So this is what we get. So now here we take the transaction and iterate the set L downwards as shown and produce the instances as shown on the right. So we cut this. So for example, let's do like this. So for example, T100 is N K E Y. TID item sets. So it's gonna be T100. It's gonna go down and again KEM. So from this, now what we produced is, so we produced ordered set is KEMOY. So this is just for an explanation. Now I'll narrate the construction of an FP tree. We make a table with the ITE, MID, support count, and node line as below. Okay, so this is what the table looks like. 1, 2, so it's going to be ITE, MID, support count, node line, so KEMOY, so 5, 4, 3, 3, 3. So this is going to be like this. So then the FP tree. So next we make a table set which contains the reverse order of an item set L. So it's just the opposite, reversed L. Reversed L is YOMEK. So let's make the FP tree now. It's the same table as above. TMID. Let's do the support count. And there you go, the node line. So KEMOY. So it's going to be 5, 4, 3, 3, 3. So from here, okay, it's going to be 1, 2, 3, 4, 5. It's just like how many digits we have. 1, 2, 3, 4. And it's going to be 1 and 2. Oh, it's only 1. That's 1. So from the table we get 1 is, so this is gonna be M still has one here. So this is M is, so it's gonna connect over here. But for this and this we have is O2. So here Y is 1, Y is 1. And so from now all this is gonna get connected over here. So now from the FP tree we construct a conditional pattern base, which is the path for the set items. So I'm gonna make this one. So this is the frequent conditional. Frequent conditional. So let's show the pattern base. This is 1. Sorry, I'm going out of table. 1. The other one is gonna be KEM 1, KE2, KE2, and here K1. So lastly, we extract the conditional FP tree, whereby we extract common item set from conditional pattern base above. So let's make the conditional FP tree. It's gonna be a little bit different. So conditional FP tree. So this is gonna be 3. So KE 3, K3, okay. So now we get the pattern as generated. So the it's the same thing. The pattern we're gonna generate. This one E. So this is gonna be N K3. Okay. So from the pattern we extracted the rules and calculated their support count. So let's give the support row. So it's gonna be Y K3 Y to K. So now based on the association rules we can determine the items that are associated, and that is all. So this is how the final tables will look on your paper. So let me just construct all the, so let me make all this paper in the same place. we're gonna call this 2. This is the ordered set. KMOY, KEOY, KEM, KMY, KEO. So there you go, the reversed. L, it's YOME. Okay. Same thing. It's gonna be the frequent conditional. So this is our first bar. KM. Two open brackets and two close brackets. Here we have for each one of this. K plus 3. K is 3. Do this step by step. So we're gonna put here the enlisted items and support count. This is basically we are just repeating the table on the same paper. MONKEYDAUCI. It's like 3, 3. We have 3, it's 2. We have key 5, 4, 3, 1, 1, 1, 2, and 1. This is how many. But that's our the least number, so we still have like 3. Highest number 5, 4, and 3. So D, and this is the item sets. So this is the one. Spot. So this is gonna be our final paper. So this is the three main diagram we're gonna build out. So this one is the first three. This is our regular FP3, and this is gonna be the frequent pattern generated. So that's how we did it. All right, thank you so much.